Hi students, welcome to this section where we deal with questions involving digit sum. Now whenever you see digit sum in a question, it's a good practice to think whether you can solve it by dividing the number involved with 9 and finding the remainder. Alright, over here we have a sample question. Let's read it. A is equal to 8888 to the power 8888. B is equal to the sum of the digits of A. C is equal to the sum of the digits of B, and it goes on like that, and you have to keep doing this till you reach a single digit. Now the question asks us to find this digit. Alright, now this question is the same as 8888 to the power 8888 divided by 9, and you find the remainder. Now let's see why this is so. Say you have a number 5738 and say let's find the digit sum of this number. That would be 5 plus 7 plus 3 plus 8. This amounts to 23, and if you add 2 and 3, that is the digit sum of 23, you will get 5. Alright, now let's try to find the remainder if you divide 5738 with 9. Now that would be equal to the remainder when you divide 23 with 9, which is equal to 5, right? Why is that so? We have seen that in the case of dividing with 9, you have to do plus plus plus, right? Which is the digit sum over here, and you will get 23 by 9 or 5. So you can see that if you find the digit sum of the given number till you reach only one digit, and if you take the remainder when you divide the number by 9, both are the same, right? You can see both are the same. Let's try to apply this in this question. Alright, over here we are asked to find the single digit number that you get when you keep adding the digits, right? A is equal to this expression over here, B is equal to the sum of the digits of A, C is equal to the sum of the digits of B, and you keep doing that till you get a single digit, and we are asked to find this digit. We have said that this is the same as doing this operation over here. Let's try to do it. Alright, so we have 8888 to the power 8888, and we have to divide it by 9 and find the remainder. Alright, now let's first find the remainder when you divide 8888 with 9. Alright, now if we want to find out this, we know that all we have to do is we have to find the digit sum. That's 8 into 4, which is 32. 32 by 9, it will give you a remainder of 5. Now as per the basic remainder theorem, let's try to rewrite this over here. Say it was just 8888 to the power 2 by 9, for example, right? As per the basic remainder theorem, we know that this is equal to 8888 by 9 remainder into 8888 by 9 and remainder, right? Now over here we have seen this expression over here simplifies to 5, and this also simplifies to 5. So if this was the expression, that would have been 5 square by 9 remainder, right? Now over here you have the power 8888, therefore this simplifies to 5 to the power 8888, and then because this value is greater than 9, you have to divide this by 9 and find the remainder. Alright, having established it this much, let me make some space over here. Let's see how we can use Fermat theorem to solve this. Over here it's good to observe that 5 and 9 are co-prime, right? Now if we have raised 5 to the power which is equal to the Euler number of 9, and if we divide it by 9, we will get the remainder as 1. We have discussed this in the section where we discussed Fermat theorem, right? Now for that, let's find the Euler number of 9. The Euler number of 9 will be equal to 9 into 1 minus 1 by 3, right? Because 9 is equal to 3 square, it only has one prime factor which is 3. Therefore the Euler number of 9 is 9 into 1 minus 1 by 3, right? That's this 3 over here, which is equal to 9 into 2 by 3, which is equal to 6. Revise the section on Fermat theorem if you want to see this again. We have already covered this, so I am moving on. We have seen that the Euler number of 9 is 6, so we need to see 8888, how many 6 are there inside this number over here, and And what would be the remainder if you divide 8888 with 6? Alright, you can either do it mentally, or say you do the division over here. You can see that you're getting a remainder of 2, right? You can do this mentally also. You don't need to write it out like this. Now, when you do 8888 divided by 6, you get a remainder of 2. Now, therefore, 5 to the power 8888 can be written as 5 to the power 6k plus 2, right? Therefore, this expression over here can be rewritten as 5 to the 6k divided by 9 remainder into 5 square by 9 remainder, as per basic remainder theorem, right? And this section over here, as per Fermat theorem, is equal to 1, and 5 square is 25. 25 by 9 gives a remainder of 7. Therefore, this simplifies to 1 into 7, which is equal to 7. Alright, so we have seen that this question over here can be rewritten like this, right? And we have seen that if you solve this, you will get a remainder of 7. Therefore, if you keep doing what is mentioned in the question till you reach a single digit, this single digit over here will be 7, and that is our answer. Let's do this question. 10 to the power 67 minus 87 is written as an integer in base 10 notation. What is the sum of the digits in that integer? Pause the video, give it a try, and then we'll do it together. I hope you have given it a try. Let's do it together. Now we'll see two methods in which you can approach this question. Let's discuss method 1. Over here you have 10 to the power 67. So that would give you 67 plus 1, that is 68 digits, right? It would be 1 followed by 67 zeros. Now if you are getting confused with this, try to simplify it. In the case of 10 square, that's equal to 100, right? So over here you have 2, and 100 is a 3-digit number. So over here you have 67. So this would be a 68-digit number. Now when you do 10 to the power 67 minus 87, that would be a number 999 etc. and ending with 13, right? And this is a 67-digit number, right? For example, if you are subtracting 87 from say 1000, what is the number that you get? You will get 913, right? So similarly, when you subtract 10 to the power 67 minus 87, you will get a number with 999, and it will end in 1 and 3 like this, and the total number will be a 67-digit number, right? This was a 68-digit number. You subtracted 87 from this number to get a 67-digit number. Over here you can see this is a 4-digit number. You subtract 87 from it and you are getting a 3-digit number. The same thing applies over here. Alright, now therefore if you find the sum of the digits, that would be 9 into 65 plus 1 plus 3, right? You will have 65 nines, and then you have 1 and 3. That's the total of 67 digits. Now if you simplify this, this amounts to 585 plus 4, which is equal to 589, and that's your answer, which is option D over here. Now let's see the second method with which we could have approached this question. Now over here we see digit sum, right? Sum of the digits. So we know that digit sum is equal to remainder when you divide by 9. If you keep doing it till you reach a single digit, right? Alright, let's try to use this and see the second method with which we can solve this question. So let's try to do 10 to the power 67 minus 87 divided by 9, and let's try to find the remainder. Now this can be written as 10 to the power 67 by 9 remainder minus 87 by 9 remainder. Alright, now we know that 10 by 9 will give me a remainder of 1, right? Therefore 10 to the power 67 by 9 also will give me a remainder of 1, right? Because for example, let's simplify. 10 square by 9 remainder is equal to 10 by 9 remainder into 10 by 9 remainder, as per basic remainder theorem, which is equal to 1 into 1. In a similar fashion, this expression over here will give you a remainder 1, and 87 by 9 will give you a remainder of 6. Therefore, this simplifies to 1 minus 6, which is equal to minus 5, and because the divisor is 9, we have seen before that a remainder of minus 5 is the same as a remainder of 4. Alright, let me make some space over here. Now let's see how we can apply this to solve this question. let's look at the answer options. You will see that only for answer option D, 5 plus 8 plus 9 gives you 22, and if you take the digit sum of 22, that's 2 plus 2, you'll get 4, which is the same value that you got over here, right? Therefore your answer is option D. Now let's see for the other options also quickly. 6 plus 8 plus 3, that's 17 plus 1, which is, that's 17, which is 1 plus 7, which is 8, which is not equal to 4. What about 4, 8, 9? 4 plus 8 is 12, 12 plus 9 is 21, 2 plus 1 is 3, that's not equal to 4. Similarly for 5, 8, 3, you can do 5 plus 8 plus 3, which is 16, and 16, 1 plus 6 is equal to 7, that's also not equal to 4. Only for 589, you get the digit sum is equal to 4 when you keep doing it till a single digit, and that's what we got over here when you divided this number by 9 and found the remainder.